Hi everyone, my name is Bhavya, and in this video I will provide an overview of my project called AI Sakhi. I will also provide a live demonstration of an AI system that powers this initiative. You can visit its website at aisakhi.org. The word Sakhi in the Hindi language means friend. AI Sakhi is an initiative to support women's health and well-being in underserved communities. It utilizes artificial intelligence as a key supporting technology, as I will explain shortly. My work is inspired by an urgent need to reimagine and invest in women's healthcare. A great body of recent work highlights systemic issues in women's healthcare and makes both an economic and social justice argument. A compelling economic argument has been made by the McKinsey Health Institute. Their report highlights that most of the health gap for women occurs during their working years, and addressing it can add $1 trillion to the global economy by 2040. It highlights that women are almost 6 times more disadvantaged than men in terms of access and effectiveness of health interventions. It points out that medical research has historically excluded women due to assumptions that the male physiology is a default, creating significant gaps in understanding conditions that disproportionately or uniquely affect women. This has led to ineffective treatments and insufficient innovation in addressing women's health needs. A human dimension has been added to this issue in the book Unwell Women by Dr. Eleanor Cleghorn. She makes the case that women's healthcare has historically been shaped by patriarchal biases, myths, stereotypes, and a lack of rigorous scientific inquiry into women-specific health issues have led to systemic misdiagnosis, underdiagnosis, and mistreatment of women. This reinforces the ethical imperative to prioritize women's health, not only as an economic opportunity, but also as a matter of social justice and equality. The urgency of action becomes even greater in developing economies, where women are disproportionately underserved by the healthcare system. Adding my personal perspective and experiences to this issue, I've had the privilege to live and attend school in 3 different countries: India, Singapore, and the US. I have seen firsthand how a combination of infrastructural, socioeconomic, and educational challenges can substantially amplify women's healthcare issues. So while the fundamental science of women's healthcare remains a problem to be solved globally, there is the urgent issue of access and expertise in low-resource environments. There are fundamentally 2 issues to be addressed here. The first is developing and scaling expertise. The second is getting underserved communities access to that expertise. My work is driven by insights into both of these issues. On the issue of scaling expertise, artificial intelligence has emerged as a key frontier. Generative AI models are now able to codify knowledge and reasoning at scale. In fact, a report by McKinsey suggests that knowledge work in particular sees a very high impact from generative AI. In particular, using AI trained specifically for a specialized domain, such as women's healthcare, holds great promise in attacking this problem. On the issue of access and distribution, technology can again be a great equalizer in low-resource environments. Even in rural areas globally, women have their own phones, and more remote areas and villages are connected to the internet. Hence, by making an expert system available digitally, it can be used both by women directly as well as rural healthcare workers deployed to villages. This brings me to the specifics of my solution. The major components of my solution are described in the diagram here. Large language models, or LLMs, have powerful capabilities to understand language and perform reasoning. You're probably familiar with systems like ChatGPT that are very effective at a broad range of generalist tasks, but are not domain-specific experts. However, they can be specialized to specific domains. While there are several ways to achieve such specialization, I've used 2 such methods. The first is domain-specific knowledge retrieval. and the second is agentic workflows that help orchestrate various reasoning and retrieval tasks with these models. This provides us a more reliable and trustworthy mechanism when using AI in a domain like healthcare. I also used AI to handle language diversity and for handling speech as a mode of interaction. Our targeted communities might be more comfortable using non-English language or using speech instead of text. So this allows my system to still be used very effectively. That is why I've included capabilities for translation and for handling voice shown here. Lastly, digital distribution also provides a natural means of targeted data collection at the point of care. We can collect highly relevant longitudinal data about symptoms, pathologies, and interventions for large populations of underserved women. Let me now switch to a live demonstration of my system. The screen shows my system as it appears to a user or a healthcare worker. It can be used on any form factor like a laptop, a phone, or a tablet. The backend of the system can be any large language model. In this demonstration, I'm using OpenAI's GPT 3.5 Turbo model. As mentioned earlier, the system is good at generalist tasks but not a domain specialist. So I will augment its domain understanding by providing additional knowledge. In this case, I'm using two pieces of data: a knowledge base on lupus, which is a chronic, often misdiagnosed disease highly prevalent in women, and a research report from the National Institute of Health on chronic conditions in women. When I upload the additional knowledge, it is absorbed into a vector database that allows the model to do semantic search before answering a question. Over time, more and more practitioner knowledge can be added to this corpus, even including data that is specific to a given population of women, a given ethnicity, or a given region. Now let us interact with the system as a user. As noted earlier, women in underserved communities may only be able to converse in regional language and only with speech. So here we have set it to Hindi. एक महिला को अत्यधिक थकान, पेट दर्द और त्वचा पर चकत्ते हो रहे हैं।
महिला को ल्यूपस के लक्षण हो सकते हैं, जैसे अत्यधिक थकान, पेट में दर्द और त्वचा में जलन। ल्यूपस में किडनी की समस्या, हृदय संबंधी समस्याएं और त्वचा संबंधी समस्याएं सहित कई तरह के लक्षण हो सकते हैं। उचित निदान और उपचार के लिए महिला के लिए चिकित्सा जांच करवाना महत्वपूर्ण है।
At the back end, I use APIs from Google to transcribe the voice using a Hindi speech-to-text AI model. The transcribed Hindi text is translated using a translation AI model from Hindi to English, because our knowledge base is in English. The choice of the knowledge corpus language is an important design decision, and English seems to be a logical choice due to a large body of domain literature available in English. Note that the system effectively picks up the question and uses the knowledge base to develop an answer. The answer is then translated back to the regional language and verbalized in that language to give a voice answer to the user. Let's continue to ask a few more questions. कौन से टेस्ट बताए जा सकते हैं?
जिन परीक्षणों को निर्धारित किया जा सकता है उनमें छाती में दर्द या संदिग्ध पेरिकोर्डिटिस, प्लूराइटिस के लिए इकोकार्डियोग्राम या सीटी स्कैन, ल्यूपस त्वचा की भागीदारी के लिए त्वचा बायोप्सी, रुमेटॉइड गठिया के लिए रुमेटी कारक और एंटी-सीसीपी, हाइपोथायरॉयडिज्म को बाहर करने के लिए थायरॉइड पैनल और संक्रमण को बाहर करने के लिए वायरल परीक्षण शामिल हैं। ल्यूपस निदान के लिए अतिरिक्त परीक्षणों में ऑटोएंटीबॉडी परीक्षण, भड़काऊ माकर, विशिष्ट अंग भागीदारी परीक्षण और इमेजिंग और कार्यात्मक परीक्षण शामिल हो सकते हैं। आगे के मूल्यांकन और अन्य ऑटोइम्यून या प्रणालीगत स्थितियों से अंतर करने के लिए रूमेटोलॉजिस्ट के पास रेफरल आवश्यक है।
वो टेस्ट कहाँ करा सकती है?
वो नासिक शहर में सरकारी लैब में टेस्ट करवा सकती है, जो उसके गांव से 25 किलोमीटर दूर है। लैब में ल्यूपस त्वचा संबंधी समस्याओं सहित विभिन्न स्थितियों के लिए निःशुल्क परीक्षण की सुविधा है। संभावित जटिलताओं को रोकने के लिए ल्यूपस का प्रारंभिक निदान महत्वपूर्ण है।
पुरुषों की तुलना में महिलाओं में कौन सी क्रॉनिक बीमारियां अधिक प्रचलित हैं?
अश्वेत महिलाओं में गर्भाशय फाइब्रॉइड अधिक प्रचलित हैं। महिलाओं में तंबाकू के बढ़ते उपयोग के कारण 2008 से क्रॉनिक ऑब्स्ट्रक्टिव पल्मोनरी डिजीज (सीओपीडी) महिलाओं और पुरुषों में समान रूप से प्रचलित है। पुरुषों की तुलना में महिलाओं में स्ट्रोक के लिए मधुमेह एक मजबूत जोखिम कारक है।
महिलाओं में ऑटो इम्यून रोग पुरुषों की तुलना में कितनी अधिक प्रचलित हैं?
ऑटोइम्यून बीमारी से प्रभावित आबादी में लगभग 80% महिलाएं हैं, जो इन स्थितियों से जुड़ी असामान्य रूप से उच्च रुग्णता को झेलती हैं। पुरुषों की तुलना में महिलाओं में ऑटोइम्यून बीमारियां अधिक पाई जाती हैं। महिलाओं में ऑटोइम्यून बीमारियों की दर अधिक होती है।
As you can see, the system picks the correct knowledge base to answer its questions, some of which were related to lupus diagnoses and some to the NIH report. You could envisage a rural healthcare center where the system can be running on a community desktop or laptop, potentially assisted by a healthcare worker or in the privacy of a woman's home using her phone. The AI Sakhi system is now hosted on the cloud, accessible from anywhere in the world. So the next step is to deploy AI Sakhi in the field. There are several important points of collaboration for this initiative. I'm looking to collaborate with medical practitioners that can provide targeted data on women's symptoms and diagnoses that can be used to prime the system similar to the lupus and NIH data I used in the demo. At the same time, I'm looking to collaborate with healthcare workers, governments, or NGOs that can provide access to rural communities to conduct a live pilot on the adoption and effectiveness of the system. I hope this gave you a good sense of what the AI Sakhi initiative is. There's a lot more to come, and I'm excited about the journey. Thank you for your time.